Hi, I'm about to go through question 1H on Math 2019, and here we have a triangle ABC which has a right angle at B, and the side lengths are positive numbers in geometric progression, and they want to know what are the two options for tan of the angle BAC. Okay, so what are the possibilities for what our triangle will look like? So we have a right angle triangle where the right angle is at B, so it's going to be like this, but we don't know which of these two angles is A and which one is C. So we could have A up here and C down here, or we could have it the other way around. So these are our two possibilities, and I'm going to label them triangle 1 and triangle 2, and let me label the sides as well. So I've called the sides little a, b and c. And we know that these sides are in geometric progression, so what does that tell us about the relationship between them? Well, for example, if we look at triangle 1, we know that B is bigger than C, which is bigger than A. So these are the side lengths in order, and if it's a geometric progression, then there's going to be a common ratio, which we multiply by to get the next term. So if the common ratio was greater than 1, we can say that C is our common ratio multiplied by the first term A, and that B is the common ratio multiplied by C. And because R is greater than 1, these terms are getting progressively bigger. If R had been less than 1, then we could have said B is my first term, C is my common ratio multiplied by B, and A is my common ratio multiplied by C, so that my terms are getting smaller going backwards. But I think I'll just stick with this case where R is greater than 1, just so we don't overcomplicate things. And we can do a similar thing for the second triangle. So now A is bigger than C, so in order we have C the smallest side, then A, then B the biggest. And for a common ratio that's greater than 1, this means we can write these side lengths out as C common ratio times C common ratio squared times C. And now we're interested in tan BAC, which is the angle at A. So that's this one up here and this one down here on the second triangle. And what's the formula for tan? That's just the opposite side over the adjacent side. So in both cases, that will be little a over little c. But because of the geometric progression, we also know A and C in terms of each other, right? So in this first one, C is equal to RA, and in the second one, A is equal to RC. So we can use that to rewrite A over C as A over RA and RC over C. And of course, we can cancel the A's in the first one and the C's in the second one. So we get that the tan that we're looking for is either 1 over R or R. But now, how can we find what this common ratio R is? Well, what other relationship between the sides of a right angled triangle do we have? There's always Pythagoras' theorem, right? So here in both cases, my hypotenuse is B, and A and C are the other two sides. So if we want to use this to find R, we can substitute in these expressions for A, B, and C in terms of R, and that will lead us with these equations. And if I write out all of these squared terms, we can see that actually we can cancel out some A's and C's. And you should always check that the thing that you're cancelling is not 0. But we know that A and C are definitely not 0 because they're side lengths of a triangle. So we can go ahead and cancel out these A's and C's, and we see that we're left with essentially a quadratic equation in terms of R squared. And I can rearrange so that it's in a form we're more used to. And so it's a quadratic equation. We know how to solve quadratic equations. So we can solve this for R. And you can, for example, use the quadratic formula. So here the x would be R squared, and A would be 1, and B and C would be minus 1. So putting that into the equation, so the formula, we get this for R squared. And we can simplify that, and we see that R squared must be 1 plus or minus root 5 all over 2. But now, could it be both plus and minus? So what conditions did we have on our R? We said that our R had to be greater than 1. But will both of these solutions give me a solution that is greater than 1? No, the minus solution would not. And actually, if I took the minus solution, it wouldn't even be positive. And we know that r squared can't be negative. So we know that we have to take the positive solution. So our r squared is 1 plus root 5 over 2. And we can square root that to find r. And again, when we square root, we get both a positive and a negative solution. But because r has to be greater than 1, we take the positive solution. So this is our answer for r. So now we know our common ratio, and remember the expressions for tan in the two different cases that we want are either r, which we now know, or 1 over r. So we get these two expressions for our tan. But if we look at the options for what we have, we don't have anything to the minus 1. So we're going to have to rewrite this into a form that fits into here. So how can we rewrite this? Well, we can write it as the same as the square root of 2 over 1 plus root 5. And now we just need to rationalize the denominator. So we'll essentially need to multiply both the top and the bottom by 1 minus root 5. And this is the expression we end up with. 2 times 1 minus root 5 all over 1 minus 5. And we can simplify that. And eventually, after all the simplifications, we see that our answer is root 5 minus 1 over 2. So the two possibilities for our tan are either root 5 minus 1 over 2, all square rooted, or square root of 1 plus root 5 over 2. And if we look at all of our solutions, that's actually option C.